So again, this is part of a series. We'll be doing several of these this year, talking about threat intelligence. We got a lot of feedback from people we were talking to, customers, people we're meeting at webinars, events, and things like that. There was a lot of discussion about, the basics of file intelligence and what we're doing with file reputation and how it fits into things. And so we thought we'd put together this series in order to help people understand a lot of the basics. And again, it's always the fun in fundamentals. So I'm Stuart Phillips. I'm a senior cybersecurity marketing strategist at ReversingLabs. I'm the technical guy on the marketing team. So I get to do demos and events and competitive analysis and all that fun kind of stuff. And so that really allows me to work with some of the smartest cybersecurity people in the world, which I really enjoy. And again, you always want to be, around people who are a lot smarter than you. So this really good, group ReversingLabs is a great place to be. And I'm based here in Seattle. And I'd like to hand us off to Fernando, if he can introduce himself.
Yep. Thank you, Stuart. So my name is Fernando Machine. Been with ReversingLabs for a bit now. Before this, I was with MITRE for about 7 years. Pretty much ran the gamut from exploit dev, SOC work, helping CPTs to get up and running, working at the combating commands, doing the exact same thing. So I've been around the mill for a bit. Currently at ReversingLabs, I am a customer success engineer, senior customer success engineer. That means just really helping the customers that we have get the most out of the products, helping them be engaged, helping them get the value out of it at the end of the day. And that involves really doing dev, threat intelligence, helping them get stood up, helping them get engaged. Yeah.
Okay. And Fernando will be doing a actual live demo at the end of the webinar, and we'll be talking with Fernando through the webinar, getting his input, especially on what I like having Fernando here because he has experience with our biggest customers and has experience with what goes right, what goes wrong, what people can take advantage of, what things didn't really work out for some customers. And so it's great to have someone who's actually had, real world experience with, especially with some of the larger accounts and some of the challenges that they faced. So thank you for being here, Fernando.
Thank you.
Okay, first a little overview of ReversingLabs. ReversingLabs has been around since 2009. We are focused on file reputation and malware detection and software supply chain security. Again, we have Spectra Core, which is our threat repository, our complex binary analysis, and our threat research teams. We do that to analyze, assess, and detect, and provide that in the form of products, Spectra Assure, Spectra Analyze, Spectra Detect, Spectra Intelligence. And again, they're all focused on different areas, but essentially all using the same core engine. So again, building on the base of our, what we do. And again, working with our APIs and integrations, working with people like Splunk and Palo Alto and Microsoft Sentinel. MISP is one of our new integrations. And so, again, being able to tie these together. And the one thing that's a little different about ReversingLabs is we're very focused. This is what we do. We don't do a lot of other things. We're very focused on malware analysis, software supply chain, and again, building on our base of base engine, which we've been building since 2009. Okay. So let's go into the agenda real quick. We'll talk about SOC operations. We'll talk about the three core types of file analysis. We'll talk about static versus binary. Static, also called binary. Enrichment, dynamic, also called sandboxing, depending. Analysis and action, and that will be Fernando doing the demonstration, and then we'll have time for questions at the end. And anyway, and thank you for joining from Winnipeg. That's great. If you want to put in the chat where you're from, we always find that really interesting. Anyway, so Fernando, let's talk about this, right? So when you're in a SOC, you come in the morning, you have 1,000 incidents, right? Or 10,000 incidents or 100 incidents locally. If you have no incidents, that usually it means it's broken, right? It's like when you pull up to Starbucks and there's nobody in line, it means they're closed, right? It's not your lucky day. So anyway, when you go in and you look at these files, the first thing you really want to do is, look at a file that's come in and it's a suspicious file. Files are suspicious for a lot of different reasons. Often a file is suspicious because you've just never seen it before. And you got to figure out, is it a good file? Is it a bad file? And we talk about this as the starting point for SOC decisions. How do you see that?
Yeah, no, exactly that, right? So detection tools generate signals, right? That's exactly what they're meant to do. And without intelligence, those signals really just remain noise, right? Intelligence is what kind of contextualizes those signals and it gives a little bit of brevity of the threat intelligence that exists and how that alleviates fatigue, by helping and adding context and behavioral understanding around those signals, right? So you get a file, that file has some individual classification, depending on what that file type was, or depending on the signal itself, if it's network telemetry or file static analysis telemetry, right? That in and of itself doesn't mean much until you go the extra mile and you start adding context behind it, right?
Yeah. And again, one of the challenges, right, and again, many challenges, but one of the biggest challenges is you can start blocking all these files, and then you get all these complaints from your
Yep.
users, like, hey, we never got that contract for that deal. The security team, screwed it up, because they blocked that PDF file that came in
Yep.
from the customer.
One of the things I've always noticed, right, with junior SOC analysts is specifically understanding that contextualization, right? What does this file mean within the context of our constituency, right? The environment, and how does this relate to bad overall, right?
Yeah.
It's very difficult to make that assessment just from a raw classification, and it often derives, that's what initializes the investigation overall.
hmm Yeah. And it's interesting to see a lot of customers now looking at AI and moving forward with AI in their SOC. And these types of questions are exactly the same, whether or not you have a human analyst or a SOC or an AI SOC analyst, or you're using different tools and things like that. It still comes down to that basic, is this a good file? Is this a bad file?
Yep,
Yeah. Okay.
exactly.
So we talk about core terms. Again, people should know these things. Indicators compromise, TTPs, context, and mean time to mitigate. One of the things we talk a lot about with mean time to mitigate, I think, is something a lot of people don't understand, and it always gets to me, is if you receive a file that's bad and it's on your laptop, and I, as a SOC analyst, isolate your laptop from the network, the threat has been mitigated. Now, your laptop is still infected. You still got a problem. You can't use your laptop. The laptop has to be refreshed or backed up or whatever, or it has to be somehow you have to remove the virus or whatever, ransomware or whatever you've done. But it is mitigated. And so at that point, you have to look at that and say, okay, we saw it at 9 o'clock and we mitigated it at 9:15. And if they come back and say, well, you haven't really fixed this, again, it's going to be this kind of problem. Okay. Do you have any comments here, Fernando?
SOC is operationalized.
Mm,
The line, right, context versus raw data, that I think is the actual core of the discussion, right? So you have IOCs, raw IOCs, that's just the data. You have the TTP mapping, right? The
mm,
behavioral patterns, that's the intelligence, right? That's how you understand where you are within the attack and how that relates. And then the MTTM, that's the outcome, right? So you have mean time to mitigate, you have mean time to detect, right? These are different, essentially, terms that determine how the SOC operates and the context around it,
okay.
right? These threat intelligence connectors and indicators, that's how it bridges it all together, from indicators to tradecraft to the outcomes.
Okay. All right, so we talk about output types. Again, this comes up a lot: true positive, false positive, true negative, false negative. Many times people get these wrong. We'll make sure we're talking about the right thing. A true positive, again, you've correctly identified the malware. False positive is the thing that really wastes your time. Your system says this is suspicious. There's nothing wrong with it, but you have to check. Again, you get in more trouble for laying through a bad file than you do for blocking things. So you kind of have to make that decision. True negatives, again, the system's working as it's supposed to. This was a good file. We found it was a good file. And then false negative, again, it is a bad file. You thought it was a good file. That's actually the worst thing that can happen, right? That's where you have lots of challenges. were files passing through your filters and your systems and finding out later that they were actual malware or things like that. And when we do a configuration uh, looking at this, we say that false negatives and false positives drive how we design and use threat intelligence. Can you comment on that, Fernando?
Yeah, definitely, right? It's a balancing act. You always want to balance to make sure you have the correct level of alerting and that you are being as proficient as possible in this. This is one of those things that in any SOC, it just comes down to tuning your detection logic, tuning the alerting, tuning how you're processing this information, and how the quality of the intelligence directly correlates to the effects of a false positive or a false negative. Poor context increases the false positives, and poor behavioral insights increases the false negatives.
Hmm. Yeah, we see a lot of customers, when we talk to them, they say one of the biggest things they want to really reduce is false positives. But when I actually talk to them, false negatives really are something that is really hard for them to track.
Yep.
So, because again, if I have a false positive, I will eventually, will examine a file and eventually find out it's good and I can track that, whereas false negatives
False
is
negative
really,
is just completely
you
missed.
really
Yep.
have no way of knowing if it was a bad file until something bad happens.
Yep. And that really goes back to tuning, right? How that iterative process of going back and repeating and
Hmm.
ensuring that your system is equalized to get to that that fine state. It's a real art.
It is an art. And it's more an art than a science. I keep telling people that
Yeah.
there's some people are much better at it than others. It's surprising. I can cook, but my wife is a chef,
Yeah.
that's the difference.
Yeah.
So we're going to talk about the three lenses, as we call them, binary, enrichment, and dynamic. Again, people call binary static. In enrichment, we talk a lot about indicators of compromise, and dynamic, which also people call sandboxing. So we're going to go through each one of these and talk about how these are should be applied and how, the best practices, best use of those. So binary analysis, again, it's looking at a file and saying, I'm going to examine this file as it is, and I'm going to, look at some basic things. So the easiest thing to do is to hash the file and compare it to a list and say, okay, I've seen this file before. It is malware. I'm going to block it. I can do that very, very quickly. Actually, that's one of our main thing. We have a repository of over 440 billion files and objects. And what will happen is if a file comes in, if it's been seen before, we can compare that. And again, also looking at like IP address and, is this on a block list? Now, this is becoming harder because of AI and people being able to create polymorphic malware. We're seeing customers are saying they're seeing malware that no one else has ever seen in the world. And as far as they know, they're the only person that this was created for. And then you have a lot of people using VPNs. We see a lot of threat actors using stolen credentials to buy VPNs or taking over systems in known places. So North Korean hackers will use stolen credit cards to buy VPN services and break into a server in, California. And then that server will then send malware to your system and you'll look at it and go, oh, it's coming from California. It's probably fine. you know. And so again, a lot of these have challenges. The strengths, again, speed. You can apply these rules very, very quickly. It's very simple to integrate them. That's not very simple, but it is simpler to integrate them into your detection rules, and it's relatively lightweight. You can build these rules with some relatively low resources. Any comment there, Fernando?
Yeah, no, I think honestly, the binary analysis piece, the static analysis piece, those are tactical indicators, right? That's like you mentioned, the quick, have I seen this before? The quick yes, no to it, right? But it really doesn't answer what does it mean for our organization, right? Which is where the threat intelligence, the context kind of picks up.
Sure.
And then over reliance on these pieces is really just reliance on data without context, which leads to, like we mentioned, alert fatigue, right? Alert fatigue leads to trust in the system, trust in the alerting structure, trust in the tools, and that kind of degrades the system overall. So it's really important to have a refined, curated list that you trust, that you can repeatedly hit, and that's where that fast approach comes in, right?
Hmm. Okay. Yeah, for binary analysis, ReversingLabs has one of the strongest tools for that. So we're able to use that as being able to, when we'll show that with our Spectra Analyze product in a little bit.
Yeah, and one of the largest corpora of malware, right? So
Yeah,
easy to make that
404.
decision
I
as
think it
well.
was like it was like 442 billion objects.
Yep.
And that's actually all searchable. That's really interesting because a lot of times people say, well, we have all these objects, but they're like on mag tape in your garage. It's like, yeah, okay.
Yeah, you have other services that will eventually,
Yeah,
move out right from the corpora. We
right.
maintain it all, keep it all searchable and static. Yep.
Yeah. So we talk about the steps, typically going through the binary steps, and we talk about that. First thing you do, you want to copy the file, right? You want to make a solid gold copy. That way, if you need this for law enforcement, if you need it for analysis later, you want to make sure that the file was not tampered with in any way. Record any relevant data, like where did it come from, when did you first see it, who was it targeted to, things like that. Hash the file, again, pretty straightforward. Make it MD5, SHA-256, make a digital fingerprint, and then do a hash lookup on a block list. Again, being able to hash the file and then compare it to a list that you have. You should be creating your own list. If you're looking at files, if you've done an analysis of a file, it's very, very simple to hash the file and then compare it to that list and give you an instant answer. I saw this last week and we checked it out and it was fine. We saw this 2 minutes ago, it's malware, block it. Again, this the easiest and cheapest and fastest way to do things. Unpacking the file, again, decompressing the file. This is actually important because if a lot of files are compressed, a lot of files are encrypted. And again, you're looking for obfuscation, right? Is there something there that's hidden? And again, that's always a very big red flag. And again, this is one thing, as we go through this, you're just looking for red flags, right? What is something about this file that's weird? It's like the next type, identify the file type. You identify it as an executable file, but it's really, it's tagged as a PDF file. Well, that's a huge red flag, right? So again, that's pretty amateurish, but we see that constantly. And again, at that point, you could say, well, if it's really an executable, but pretending to be a PDF, then that's a big red flag. I have a high reason to believe that this is somehow suspicious or malware. You can run static checks against at that point. You can do antivirus or string checks or Yara, and then you can also do a metadata review. You can look at it, the information, where it came from, things like that. And then again, if you do not have anything to indicate at this point, you still have a suspicious file. You don't have anything here that's a further red flag or any reason to clear it, then you probably want to move on to your next steps. And you have comments here, Fernando?
Yeah, definitely. One of the things you mentioned earlier, right, was polymorphic malware, how easy it is for an adversary to change, right, the hash of a file, right, or make a change to a file that essentially hashes the file, which would break this, right? So one of the things that is really important is to be able to fast and editor to look up a hash, right? Is this known? Is this unknown? And then how that translates from there, right? If essentially you get a block at, that 3 line in the analysis steps that you're looking at, you don't have to worry about the rest because you already have that known file reputation, which is really what is key for speed and effectiveness, right, within the SOC.
Hmm. Yeah, absolutely. And again, to me, I'm just looking for red flags, right? And at some point, I have some customers who are like, okay, I want to examine a file. I want to, really find out everything about this file. I want to write a PhD thesis on this file. I want to do a Security Boulevard article on this file, that kind of thing. And then I have a lot of my SOC friends who are just like, look, if there's any reason to believe that this is suspicious, I'm just going to mark it dead. And so if it comes in and it's all encrypted and has weird and obfuscation and all these kinds of things, I'm just going to decide at that point it's malware, and we're going to go ahead and block it, and then we'll file the incident and see what happens. But again, I'm not going to let a bad file into my system.
Yeah, especially right, depending on what specifically is the ecosystem that you're in, right?
Right.
What
Yeah.
services you're trying to provide, what level of operations you need to maintain. That really takes into effect if it's just going to be a further analysis or, like you said, a red
Right.
flag that's gonna
Right.
stop.
And again, talking about binary and analysis in practice, we talk about where it shows up. It shows up in your, signatures, your gateways, your firewalls. Again, the real benefits, it's very quick. You can, and it's also basically give you a real long, strong baseline protection at scale. I can do static analysis on every file that comes in. I don't care if, again, if I get a million, I have customers that do a million files a day and they do static analysis of that. It's quite possible. It's easy to scale. It's straightforward and it gives you very consistent results. The risks, again, 0-day type attacks and things that you've never seen before become harder and harder. Uh, if you're using stale intelligence, again, causing a lot of false negatives, and this is one thing we talk about a lot, and over-reliance on lists, right? If the file's on the list good, if it's not on the list bad, again, the question is how quickly or how are you updating those lists? I think, one thing you and I were talking about before was stale intelligence and people using like a lot of these free threat intelligence lists, but their data in them is they never prune the data or never, remove the data. Is that you find that to be correct?
I found that to be incredibly correct. I found it to be one of the biggest issues that we have in the space, right? So when you're looking at stale data, that really leads to miscategorizations, right? It leads to potentially unwanted results and effects on the SOC that are going to have
Mhm.
detrimental, right? To mean time to detect, mean time to mitigate. Those are things that, as a SOC, as you're looking at your data sources and your data feeds, you need to be really cognizant of, right? What are you consuming? Trash in, trash out, I would say.
Right, trash in. And again, that's one of the things I asked like the SOC managers and the threat analysts and things like that are how are you evaluating your threat feeds? How are you deciding what to use, what not to use, and when, who's your audience for this, right? You have a threat feed that's providing a lot of nation state information. That's great, but you have no one in your organization cares about that. So you're wasting a lot of your time. And unfortunately, well, a lot of times when I say, why are you using this? They say, well, it's free. It's free, therefore, that's good for us. Okay. Right. So this is a screenshot from Spectra Analyze, and we'll be doing a Spectra Analyze demo at the end of the here. But this is an example of a binary analysis in action. And what will happen is here's a file that came in. We'll identify the file type. We'll identify the format. We'll do perform a risk score on this. We'll identify the threat actor. Again, looking at Yara matches, community threat detections, which is, antivirus, things like that. And then we'll do, the static analysis detected it as malicious. We went ahead and sent it to the sandbox, and that also came back with more information. And then again, the sample information, all the indicators of compromise and everything, here. And then we also went ahead and created the sample description. And actually, we use AI now to generate these. And so they're continually updated on a daily basis. But this is the kind of information you would get with Spectra Analyze and being able to, pull the information from the file and then being able to do it. And then you have the hash. You can also, again, take it from here. You can reanalyze it again if you want to, and you can go through and check it out. And
Yeah,
then this is an example of the same file. We sent it to, with Inspector Analyze, we're connected to 35 antivirus engines, and those are all sent up automatically for you. So what will happen is we will submit the file to all of these antiviruses, and we'll give you information back, and we'll tell you what this is. And the nice thing about this is we actually don't share your information with anybody else. So you're not going into it's not a community type thing where it's all like shared and someone can read, your executive's emails and you have a problem and people end up talking about you on Slashdot or something like that. Or on Reddit was my favorite. Anyway, and then, but again, the idea is we have the relationship with these antivirus companies. We will hash the file, we will submit it to them, and no one will know that it came from you. So it will be, you're basically obscured from the end users and the other and so this will go out to all of these, and it'll give you an idea, did these antiviruses see this or not? And so this is again one of the best things to do. And the nice thing here again is you automatically get all 35. You don't have to go and buy them in clumps or four at a time, or pick the four that you want or something like that, or the ones you think are best because you don't have you know, a good way of knowing that beforehand. So again, this is how we would do it within Spectra Analyze. Okay, so moving ahead, we'll talk about enrichment analysis. Enrichment, again, we talk about indicators of compromise. We talk about basically the information about the file. And this is what example, like where did it come from? Now, obviously, if it came from North Korea, that would be really easy, right? If it was, if everything was just that easy, it would be nice. But it doesn't. And again, the whois data, it came, this file came from a domain that was set up 20 minutes ago. Historical insights, we've never seen this file before. That's always a red flag to me. We see this file. Everybody in my organization received this file today in their email. That also is an indicator. Threat actor mapping, I can do some Yara searches and look for text strings just for different things. And again, how critical is this? So for example, I may be putting in together information to say, I'm going to look at files that are sent to my executives much more than I'm going to look at everybody else's file because they are targeted substantially more than my regular employees. People who do accounts payable are much more targeted than people who do accounts receivable. So again, being able to, look at you being targeted. And again, we talk about this a lot, right? What is this what does this mean for us? How do you think that fits, Fernando?
Yeah, I think this is a transition from identification to meaning. I think this is a transition from data to intelligence, right? So when you're looking at the different levels of intelligence that you have, tactical, operational, strategic, this is how you get from tactical to operational to strategic to exactly understand how this affects your organization. Is this a campaign that's targeting you, right? Is this a specific threat actor that's targeting you? How does that identify what is happening and how you can continue to defend and actively generate a posture against it?
Okay, thank you. So again, we look at this and say, here are the types of things that you would look at. Reputation score, has somebody else previously said this is malware? Again, we'll read through all these, but these are the kind of things that you would look at to say, what are the things I'm interested in? Why is there any piece of information here that I can make a decision? And again, you've got a file, you applied binary analysis, you weren't able to figure out if it was malware or not. At this point now, you're applying additional rules and you're trying to get more meaning out of it, right? Trying to understand this a little bit better. And again, look, my favorite is file type, right? We see that a lot where they're obscuring the file type, and that doesn't make sense. Unsigned files are suspicious, especially when they're supposed to be coming from somewhere that's trusted, but you look at the files unsigned. Um, and looking at URLs, domains, IPs, coming at things like that. So, which one of these do you think is more important than others, or how would you rate these, Fernando?
Honestly, I think it depends on the organization, what the organization is looking for, to be honest with you, right? So I think if you're looking at a large scale organization that has potential like campaign tracking, having the malware family string match, right, and being identified as a campaign that's normally attacking us, and we have a playbook essentially
Mhm.
that tells us how to defend against it, I think that's a key. First versus last seen is another great one, right? How often have you seen it? When was the first time you saw it? When was the last time you saw it? How does that delta, right, in the file type deviate, right? How does this deviate from the different samples that I've seen that are associated with this? And how does it potentially fall and through the gaps in my detection logic, right? I
Mhm.
think there's a lot of that you can take from this. I think this could be an entire talk in and of itself, to be honest with you. But really, it's scoping these down to your individual organization, right? And what really you've seen and how that matters. That's how intelligence transforms it, detection logic, and the enrichments essentially do that.
Yeah. Well, we'll be doing a series of these webinars if our audience thinks that this is something we could really focus on or be more informational. Please let us know. We'd be very happy to provide that type of webinar. So Yara rules. Yara rules are an area which, again, I think everybody on here should know and understand. And again, it's being able to scan the file, looking for information. A Yara rule has basically four components: a name, this unique metadata, looking for tags like author, description, malware family, references, string selection, condition selection, right? So look for certain text and looking for certain logic within that, and to say, what are the conditions that I have four strings. If I see two of them, great. But if I only see one, then I still don't think it's necessarily malware. So a lot of, it's interesting, a lot of malware types and names and things like that, they actually come from string text that are found within them. And so if you're talking, if someone's talking about a piece of malware and it has a strange sort of name, it was because when someone ran a text scan across that file, they were able to find some text with matching that name, and it shows up consistently in that malware. And again, a lot of this is because hackers use the same malware tools, generation tools. They're reusing malware quite a bit. They're using malware for hire, which is, it's literally renting the malware to use and these types of things. And so, it's interesting. Fernando, when I'm in talking with people that are really interested in getting into SOC work, the two things I tell them is they really should focus on, one is learning automation tools, and the
Mhm.
second is they really should be good at Yara. I
Yeah,
mean, what do you think about
Yara.
that?
Yeah, Yara is to me, right, one of the quintessential things how intelligence gets operationalized into detection logic, right? So we talked a lot about intelligence, what it is, how it does, how we can utilize it, but it's not intelligence themselves, right? They encode what we've learned thus far from the different samples after enrichment and how you can essentially operationalize to your benefit, right?
Mhm.
I think YAR is one of those things that it's a combat multiplier within a SOC, and if you're not effectively using it, you need to take the adequate amount of time to learn it and employ it effectively because it really is the Swiss Army knife when it comes to a lot of this stuff. Automation is a whole nother key, right? But if you don't know how
Right.
to effectively employ the automation around it, then you could be essentially drowning, right? If you just have automation logic to raise alerts, that's another cause of alert fatigue.
Yeah, don't turn on the alarm without figuring out how to turn off the alarm at the same
Exactly.
speed, right?
Yeah.
Yeah, thank you. So this is just a real quick demonstration of one enrichment. So this is from Microsoft Sentinel, this type of incident. So what will happen is a file came in. The name of the file was bluestub.exe. It's a weird file. It's an executable file. It's encrypted. It has never been seen before. However, it did come from Microsoft. So I'm going to mark this as good. So if a file comes from Microsoft directly, and Microsoft's within my known good list of vendors, I'm going to go ahead and mark that as correct. Now, obviously, that could come back to bite me, but the amount of time I'm going to spend looking at this file could be significant because it might have been sent to everybody in my organization as part of some sort of update. And I want to make sure that it's okay before I do it. But I'm going to look at this file and say, well, it came from Microsoft, and for that reason, I have reason to trust it. I will check to see if it's signed by Microsoft, if it's signed correctly. I have reason to believe that this is an okay file, and I will go ahead and mark this as good. I mean, what do you think, Fernando?
No, I think one of the key things there, right, is you're looking at trust factor. The way that we determine trust factors, right, is utilizing that large corpus that we have of file samples, right?
Mhm.
Amongst a couple other methods that we utilize it. But understanding how trusted that is, and I get it's a little misleading, zero is it means very trusted, and five would mean not very sure what this looks like. I think that's one of the best ways to get an understanding of what you're looking at and enriching overall to make a
Mhm.
decision from.
Yeah, and again, the nice thing about using these tools and populating the incident is being able to say why did we approve this, right? If you look at this next month and someone comes back and says, why did you approve this file? You have all the information here. Everything is well documented. So again, looking at dynamic analysis, moving ahead. A dynamic analysis, again, is what we call sandboxing, behavior analysis. There's a lot of different ways to look at this, not just sandboxing. You also have a lot of anomaly detection systems, which are becoming more popular. But again, this is a point where you have a file, it was marked as suspicious, you think it's malware, um, you know, you collect the indicators of compromise, you use that, and then someone says, I want more information about this file. I want to know what it does. I want to research it. And this is an interesting area because I know everybody really wants to do all this stuff. The challenge is the amount of resources and time and effort and basically skills, right? It's harder to do this. I know for myself when I'm sandboxing stuff, it's a lot harder and it takes a lot more time, things like that. And so one things we'll ask with organizations, they'll say, if you sandbox this, if you detonate it, if you run it and get all the characteristics of it and it works properly, what are you going to do with that information and how quickly can you use it? And so that becomes one of the challenges is, information is fleeting, right? If I'm going to find out something about a file, if I'm under an attack, minutes count, right? I can't, put this into a backlog and say, well, we're going to look at this in 3 weeks once we get through all these other files, and 3 weeks is going to be a miracle because,
Yeah.
it's like, that kind of thing. Do you see that too, Fernando?
Yeah, I do, right? And so the way that I look at dynamic analysis is indicators change, right? We talked about IOCs being the raw data, but the tradecraft, right? What the TTPs tell us, they change more slowly. It's much harder for an adversary to change the way that they're employing a specific mechanism, right? A dropper, a loader, et cetera, as opposed to just the hash that's associated with that file. And so behaviors really tell us how the adversary operates, right? Not just what file they use to do so. So there is a push-pull mechanic, right, between the cost benefit of doing the dynamic analysis, but I think really it's reserved for those that are uh, capable of deriving the information that's necessary to push the investigation forward within the SOC.
Thank you. We talk about the trade-offs. First is it really gives you safe execution of malware. Every SOC operator I know, or security professional, that tells me a story about, someone saying, "Hey, I got this weird file in my email. I just emailed it to you." Yeah, don't do that. It gives you behavioral insights and it gives you a rapid analysis of zero-day attacks. So if you are under attack, if you are seeing this, you can go ahead and detonate it in a sandbox and get better characteristics of it. Challenges, again, ever changing evasion techniques, right? I mean, used to be malware would look to see if you're in a virtual system. If you were in a virtual system, it was probably a sandbox. Now that ubiquitous now, almost everybody runs virtual systems, so that's not true anymore. So that becomes it's skill dependent. Fernando, I would believe that you'd be much better at this than I would. So if you ran it versus I ran it, or that makes a difference. That's actually resource intensity, depending on number of files I want to run. I know a lot of, talk to customers, they're like, oh, I want to send every file to a sandbox. It's like, okay, well, then you need 1,000 sandboxes. How much is that going to cost? Okay, well, we're not going to do that. Okay. And then also, it is, limited in the realism too at some point. You do have to understand, you can see sort of the initial triggers and things like that. But long-term behavior of the file, if it's going to sit dormant for 6 months and things like that, those are challenges that maybe we won't be uncovering.
Yeah.
And so again, you have to be realistic in what you think you actually will uncover and what you will see. Do
Yeah,
you have any
there's
comments?
there's
Yeah.
yeah, there's serious limitations to it, but there's also good trade-offs, right? So like you mentioned, being able to perform an interactive and dynamic analysis, right? Versus just an automated dynamic analysis. A lot of malware nowadays will have feature sets that'll cause to pick up and essentially go dormant and not do anything, right? So how does that get determined? How does that get operationalized and actionalized, right? To get
Mhm.
and extract the information that's necessary.
Mhm. Yeah. Thank you. So again, questions to ask. Do you have the resources? Are you able to leverage this information? Can you do this in a timely manner? And what is the shelf life of this information? If you're seeing brand new malware that's never reused, it can be very challenging to say, well, you know, I'm going to put a lot of thought into this malware, but if I never see it again, I don't know, it's interesting and make a great, you know, dark reading article, but it doesn't help me because I'm not going to ever see it again. And can you leverage this information? Are you going to take this information and do something with it immediately, right? If I run it in a sandbox and I find that this malware changes a registry entry on all my Windows machines, am I then going to turn around and search all of my machines for that registry entry? If I'm going to put it into a book or into a log and not do anything with it, it's not really helpful. You really should be doing, our position is you definitely should be doing sandboxing. You should be doing sandboxing when it makes sense, and you should be leveraging that information immediately. And that, people who come in and tell you you should sandbox every file every time, those are the people that sell sandboxes. And so there's a lot to be gained from sandboxing and from these types of, dynamic analysis, looking at behavioral, characteristics, things like that. Files that do weird things in the middle of the night, absolutely. but are you going to take advantage of that information? And you should be really focused on things that you can, is this actionable intelligence?
Yep.
You know?
Intelligence maturity is a real thing that you want to strive towards as a SOC, right? So
Mhm.
yes, it's more resource intensive, but it's really more resilient against evasion. And that's really one of the things that you want to start incorporating
Right. And
in your SOC modeling workflows.
this is one area where skills and expertise really come into play, right? If you're going to do this, you really should learn it and really put some effort into becoming an expert at it.
Yeah.
So again, this is an example. We're using the MITRE attack matrix here, which is coming from, this is an example of a file that was sandboxed within Spectra Analyze. And again, the status is pretty straightforward. You submit the artifact, you execute the sandbox, you monitor the behavior, and you generate a report. And we do all that automatically. And coming back to attack matrix, what we saw happen is it tried to escalate its own privilege. It tried to avoid the defenses, and it started doing discovery across systems, its own system and other systems. Huge red flags and things that you would not expect a normal file to do. And so these are the kind of things that you would look at, and you would take this information to say, okay, I'm using this antivirus, I'm using this EDR, this malware tried to evade it. Was it successful? If it was successful, I've got a real problem. If my EDR detected it within seconds and blocked it, that's great. But again, these are the kind of things that you need to do. And so again, you want to be running sandboxing. We always recommend that you run this on like production type systems. It doesn't, this is not a learning exercise where you run it on a vulnerable system or, you know, uh, an unpatched web app or something. You want it on your production system that's updated, and you want to see how it affects your systems directly. If it was able to upgrade its privilege, that's something really worry about. If it's doing discovery, is that something you can detect with like, Wireshark or your firewall rules or something like that? And if it is, are you looking for that? If all this file started looking, doing scans across the network, are you looking on your internal logs to see if you're scanning systems? If it turns out you have 1,000 systems and 980 of them are doing these types of scans, you've got a problem. So again, this is the important thing here is to understand the scope of the problem, right? If you have 1,000 systems and only one of them is doing this type of discovery, then it's still a problem, but it's just a different scale. And do you see that when you were at MITRE, right? You worked a lot on this and this type of
Yeah.
thing. MITRE's again one of the nicest things I like because it's so easy to explain to people, especially non-technical people, like what is actually going on.
Yeah, and I'll tell you what, in my experience, especially with slots, right? MITRE attack is one of those things that it's easy to understand, but it's hard to operationalize, right? Specifically, how the techniques or the tactics that you're seeing employed, how those relate, right? One of the things that I've seen a lot that has a lot of value is where you have potential coverage gaps, right? Or specifically where the malware sample is going. So if you have two malware samples that are familial classified and related, do you see new behaviors that you didn't see before from that specific sample set, right? Does that mean that the adversary is evolving and is trying to employ a new discovery technique, right? Are they trying to employ a new lateral movement technique? Those are things that really help you harden the profile against that individual adversary.
Okay. So again, here's coming back to a sort of conclusion, static, enrichment, dynamic. Absolutely should be doing all three of them. They have different places. Static is something that has the lowest cost, easier to implement. Again, you should make sure that you have a very, strong, binary analysis going on. Enrichment, again, is, enables you to make decisions about suspicious files. It's a great place to employ AI. If you're using AI tools, it's one of those things where you can start using AI to gather information. Honestly, I see SOC operators still typing who is space domain name into a terminal prompt. That's very challenging, right? You really got to start looking at these types of things and saying, what can AI do for me? What are the things that we can take advantage of? And again, because a lot of times with reversing labs, because most of the times you communicate with us through APIs and things like that, you're able to take advantage of AI tools. And we're seeing a lot of our customers doing that now, where they're writing their own tools and they're using us to provide the analysis, but then acting upon that analysis, doing that information. And dynamic, again, difficult to implement, expensive, but it does give you a final answer, and it gives you basically ability to do analysis. But again, I'll come back and say, are you really doing analysis? Are you really going to use this information? And you really should be doing dynamic in certain cases where you can really take advantage of something. If you believe that you're under attack from bad actors, and you're seeing certain types of malware, you definitely get those into your sandbox, get those into your anomaly detection, and then start creating rules, start updating your Yara, start turn on the Wireshark, get it going, and again be able to stop the attack half in progress. You don't want to be wait until that malware has detonated. Okay, all right. So at this point, I'm going to go ahead and hand this over to Fernando. We're going to go ahead and do a live demo of Spectra analysis and I'm sorry, Spectra Analyze, and we'll go ahead and do that. And so we'll hand over the screen to you, and I will go ahead and stop sharing.
All right. Let me know when you guys can see the screen here. Did the screen come through?
Yep,
Stuart?
we can see it,
Yep.
Fernando.
All right. Awesome. Thank you. Yeah. So this is this is analyzed, right? So we're looking at a specific sample here. You get a lot of information off the cuff, but there's a specific things that I like to look at, right? That'll kind of go in line with what we've seen from the presentation thus far, right? So you have your immediate risk score, right? What does this mean overall? How do we do risk classification, right? We look at specifically, we said goodware. How does this fall within the goodware range? And then is it suspicious, malicious, and how does that interact, right? Overall. Then you get the threat actor name, classification type, right? How we could reach this classification. You see a couple of different classification engines, and we utilize static analysis, dynamic analysis, a threat intelligence, any auxiliary analysis was performed, network analysis that was performed, right? And then this is where we have obviously for other integrations that allow you to either ship this information out or utilize it within your SOC. The community threat detections is the same thing that so we're talking about, right? How the AVs play, and then if there's any YARA matches that align with this. This is really just your big everything's on fire. I need to look at this to see what to do, right? And how to pivot from there. On the left-hand side, we break it down into static, dynamic, and then the auxiliary and the threat intelligence. The actual screen itself gives you sample information, right? But also relational graph. How does this relate to other samples that we've seen via RHA similarity? So we see right there, looking at the similarity scanning that we utilize, there's a 1.61 other samples that are related to this sample, right? So being Lockbit, that makes sense, right? It's a known ransomware group. It's a known ransomware sample. It's doing a lot of things. From there, the sample details, we kind of break it down, right, on the file analysis side into even more detail, right? What is the malware description? What's the ransomware? What are the details associated with this individual sample? And how we caught this kind of goes into the mix of what are the specific classifications that led this to be caught. Essentially, we classified at the rate that it was. We pull MITRE ATT&CK as well from the static as well using a couple different methods, right? But this gives you an overarching view of within the entire attack technique grid, right, where it falls, what it was doing. And you'll see later on this gets enriched, right, when we do dynamic analysis, because it's only so much that static analysis will let you, pull back. But within that, you have interesting strings, tags, extracted files that are associated with it, right? Just from the static analysis. This is, like I said, that raw bit, right? That we're just pulling out as much information as we can from that file and kind of categorizing it as best we can, right? So we have indicators associated with it. We do individual classifications associated with it, right? Like I said earlier, threat reputation, Spectra Core, which is the engine, machine learning, and next-gen antivirus. And then from there, we move on to the dynamic analysis, right? And all the individual pieces that come with this, right? So the big one here that I like to always point at is the behavioral itself, right? What are the behaviors that were observed, right? Registry modifications, mutexes, modules loaded. This gives you a really good inference on how you'd want to potentially craft a rule for the specific file that would potentially survive just a hash change, right, by the threat. And then furthermore, right, the MITRE ATT&CK, how this kind of plays into what the adversary is intending to do, right? So we see there's system time discovery, file discovery, system information discovery. This is a lot of host-based discovery that you would normally see from a ransomware, but also there's masquerading associated, right? So now I need to be careful of the file type. Is it looking, pretending to be something that it isn't, and how is that affecting me, right? And then the fact that it's doing collection to some degree at so is also limiting, right? So you may want to, if you have shadow copies, may want to activate shadow copies, right? If they aren't already active in your environment, things like that. These are like little tidbits that allow you to kind of get a better sense of what is a sample intending to do, what is a malware intending to do, how is it doing it, and how do you build robust systems around it. And then lastly, it's the threat intelligence piece, right? So we have the community threat detections, which is the AV engines, right? But also we have the file similarity, right? Which shows you from all the samples that we have, this really helps you build out a good known of what else is happening within files that are associated with this. You can look through different suspicious classifications. This helps you write YARA rules. This helps you look at how do you increase maturity against this individual threat overall.
Yeah, I
Anything
think
I missed, Stuart? Anything you want to add?
no, I'm just saying it's just, I mean, again, this is all gathered for you automatically, right? By
Yep.
Spectral Analyze. So this is
Yep.
again, I talked to one of our customers. He was like, he's found this malware. They're going through it, have a problem, blah blah blah, all normal stuff. And he's told that someone in leadership is really worried about this, and he has to do a presentation to the board of directors in 15 minutes.
Yep.
So it'd be good if he has some solid information. So he was able to take screenshots and pull up analysis and files and reports and have all that ready to present, but actual factual information. What are we seeing? What are we seeing here? And again, doing that. Um, it's amazing. I mean, it's amazing how much information you can gather and be able to act upon, and then if you can automate these and push this into different things, it becomes, very powerful for you. One of the questions we had, in the chat. So, when we talk about maturity, right? Maturity is a real big issue with these types of analysis. How do you think maturity, of an attack and all that kind of stuff fits into this type of environment?
Um, yeah, so I think, right, you're talking about the maturity of the detection itself or the maturity of,
The life cycle of, I'm sorry, I meant the life cycle.
yeah, so the life cycle, the sample itself, right? Is
Right.
what you're saying? Yeah,
Yeah.
right. So that's one of the things that it makes it really easy to discern, right, from having this depth of analysis, right?
Mhm.
Understanding specifically how that sample is evolving and potentially where the adversary is intending to go next, right? So is there a dropper? Is there some file exfiltration that is happening? What does the kill chain look like, and how do I get to that stop of the kill chain before it progresses, right, too far right of bang?
Mhm. Okay, that's a good question. If anybody has any other questions, please put them into the chat.
Yeah, I think we
Um,
have we have a question from Shari. Yeah, so it said, does this include a MITRE playbook for detection analysis like YARA rules or playbooks for MITRE code? So we do have our own internal YARA rules, right? There's a plethora of YARA rules out there that allow you to kind of tailor, right, and gives you a starting point to work off of. But yeah, this is definitely something that we have a YARA section that allows you to curate your own rule sets. It lets you do retro hunting against the entire corpus to see how your rule set stacks up against what's already there. There's a couple different ways that it can do it.
okay, that's good. Yeah, that's good. Good question. There's a question. So, normally our customers are, um, we're seeing a lot of customers who are moving off of Virus Total right now. Because they were acquired by Google, and Google has bundled them with Mandiant and really, dramatically raised the price. So I think a significant number of new customers we had this year are people who are moving off of Virus Total and replacing them. We actually have a new API that actually allows you to take, if you've written custom things for Virus Total, you're able to convert them into Reversing Labs. And Fernando and the customer success engineers can help you actually move that over. So we're seeing that a lot with people who are not interested in buying, a bundle of tools especially our MSSP comrades who are finding that if I have a new I have to buy this, but then I can't sell it to my customers. That really affects my bottom line, especially in a lower margin. Margins are real tight no matter what business you're in right now. And so we're seeing that quite a bit. So a lot of people are moving away. And you'll see a lot of information on our website about us versus Virus Total. Again, being able to move forward if you're interested in a demo or you're interested in, there's some links in the chat, be able to put that information out there to be able to find how to, transition off of Virus Total if you're looking at, not necessarily wanting to pay significantly more for tools that you're not going to use. And you'll see some really interesting things that we're doing there. Anyway, that's why I wanted to close on that. We're at time. Fernando, every time I've talked to you, man, I get smarter. So I really appreciate that. It's one of the things I really enjoy. I want to thank everybody for joining, especially, we started, we have pretty much everybody. That's what I always look at, what did we start with? What did we end with? And most of you stayed through the entire thing. So I really, really appreciate that. If you have questions, please reach out to, stuart.phillips@reversinglabs.com. Really straightforward. If, I'm on LinkedIn, if you want to post a message there, if you want to contact us and about getting a demo, getting a trial out in your organization, we'd be very, happy to talk to you about that. If you have further questions, but you don't want to post them right here or talk to them, that's great. We don't understand that, absolutely. We're very happy to talk to you. But I'm looking forward to hearing from some of you. And again, if you have ideas for other webinars or things that you would like us, you saw, but you want us to spend much more time on get a better understanding, please let us know. We're very happy to, that makes it much easier to when I'm doing my planning. So that's great. Anyway, but thank you very much, Fernando. Thank you very much. As
Thank
always,
you,
thank you
Stuart.
to Joanna, who is our organizer, who without her, nothing would happen. And so really, really appreciate that. And so all have a great day, and I hope you learned something or it reinforced what you already believed. And if you don't agree with me, reach out. I'd love to talk to you about it. Okay. You all have a great day. Thank you very much.
Thank you, everyone.